The world as we know it is changing. With limited resources and their mindless usage, natural calamities and adverse weather conditions are becoming a very real threat. Environmental concerns over sustainability is constantly on the rise. Evidently, modern science is in a steady lookout for renewable resources. Nanocellulose can provide one such solution. Derived from various biosources, including algae and plant biomass, nanocellulose is a lightweight substance used to manufacture high-strength and durable materials. In India, Central Institute for Research on Cotton Technology, popularly known as CIRCOT, has been researching nanocellulose for over a decade now. The decision to set up a plant emerged out of 10 years of concerted efforts by a team of multidisciplinary scientists. Their research led to 3 novel energy-efficient protocols for production of nanocellulose: chemomechanical, biomechanical, and microbial processes. The stage was all set for a pilot project. Backed by substantial research and preparation, the Indian Council for Agricultural Research established India's first nanocellulose pilot plant in the year 2015. The pilot plant on nanocellulose was inaugurated by the renowned scientist Padma Vibhushan Dr. R.A. Mashilkar on 21st August 2015 at CIRCOT headquarters in Mumbai.
It is a unique pilot plant in India producing the nanocellulose from the cotton linter and cotton waste. These nanocellulose having unique applications in the field of paint and paper industry, in a rubber industry, in cement industry, as well as the slow release for the fertilizer, which is very helpful for the farmer.
Supported by the World Bank funded NAIP project and with a budget outlay of 4 crore rupees, the plant has a capacity to produce 10 kgs of nanocellulose every 8-hour shift. Production of nanocellulose entails a number of stages. To start with, shredded raw materials are fed into the pulper, where it gets heated and stirred. Once the pulp is ready, the beater with the heavy-duty roller takes over, beating and shearing the pulp simultaneously. After beating, a pulp pump transfers the material into a tri-disc refiner. With its for refining surfaces, this refiner produces enormous amounts of shearing action on the pulp that leads to fibrillation and size reduction. Once fibrillation is done, the material is passed through a screen to separate the coarser material, which is brought back to beater for further fibrillation. The finer materials are passed for further processing in a high-pressure homogenizer. Inside this, the material is pushed at a very high pressure of around 40,000 psi through a series of reaction chambers. During this process, due to shearing and cavitations, the size gets reduced further and nanocellulose is formed. The nanocellulose can then be used either in slurry form or powder form after freeze drying. The pilot scale freeze dryer used here dries the slurry without affecting the physical and chemical nature. The Institute is trying out numerous potential areas of application that includes nano-composite films for food packaging, high-end paper coatings, reinforced concretes, reinforced natural rubber. Developing new products is high on the agenda of the Institute. ICAR-CIRCOT has patented the novel energy-efficient processes of nanocellulose production being used in this pilot plant. It is now available for technology incubation and licensing. The pilot plant is also being used as a platform to demonstrate and validate the production technology. For the incubation of entrepreneurs and industrialists, ICAR-CIRCOT conducts training programs and technology demonstrations.
This pilot plant uses eco-friendly processes for production of nanocellulose from cotton and other agro biomass. Our focus is to integrate this high-end technology with the agrobiomass so that the farmers' income increases and the society benefit at the end.
The product, Nano cellulose, exhibits unique properties like extraordinary strength, very high specific surface area, novel rheological and optical properties. And the entire range of its applications has huge potential, much of which is yet to be explored. Technology of tomorrow available today. With nanocellulose, the future is right here, right now.